Hello and welcome. Thank you, Garth. Hello and welcome to the first talk in our Environmental Speakers Series. My name is Sandra Milligan and I'm president of Greenways Land Trust. I would like to acknowledge that Greenways projects occur on the traditional territories of the Kwakwaka'wakw, Coast Salish, and Mowatsit-Muchelet First Nations. They have been stewards of this land since time immemorial. Working with Greenways Land Trust, I'm honored to live and be a participant in current stewardship projects on this land. This fall, the Art and Earth Festival was hosted by the Campbell River Arts Council, the Museum at Campbell River, and Greenways Land Trust. Its goal was to heighten appreciation for our natural world. This speaker series was born from the desire to continue that conversation. As well, the museum wanted to continue bringing expert speakers from the UVic Speakers Bureau into Campbell River to share their knowledge. I would like to thank those who put this speaker series together, including Ken Blackburn from the Campbell River Arts Council and the museum, Eric Anderson from the museum, and Lydia Stratman from Greenways Land Trust. They are all in our virtual audience tonight, and do feel free to use the chat if you would like to connect with them. Now, for a few housekeeping notes, the bathrooms are out the door to the right, and there's some wine and soft drinks in the kitchen. And no, but seriously, some of the benefits of being at an online presentation are that you are in the comfort of your own home. More than that, you have the chat. So when a question arises during the presentation, you don't have to hope that you're going to remember it for the end. You can put your questions into the chat whenever they arise, and you have your keyboard. So, you know, when you try to ask a question in a presentation, you never quite word it properly, you have time to craft the question of your choice. Garth will be speaking for about 40 minutes, and we will have 15 minutes to answer your questions. Now, for the highlight of the evening, we are happy to have Garth Covernton with us from Victoria. Garth is a doctoral candidate in the Department of Biology at the University of Victoria, my own alma mater. From his publication record, though, you wouldn't think he was a graduate student still. You'd think he graduated a while ago, with 7 publications in the last 2 years, 4 of which are first author publications. I'm green with envy as an academic. It's an impressive list pre-graduation. His research is highly collaborative, working with researchers from the US and Europe. It's covered bivalve ecology, as well as a measurement of microplastics in marine environments. This research provides foundational knowledge about how we can start to study microplastics. And this will allow us to move forward to do more studies to better understand our impacts, the impacts of our love of plastics on the environment, but also directly on us. One paper that I found particularly interesting provided an estimate of the amount of microplastics that we consume annually. In this paper, they looked at the cumulative effects of consumption of water, sugar, salt, beer, and seafood, and found that people would consume, eating just those things, about 50,000 particles of microplastics. And I was a little bit concerned because unfortunately in my case, I think I'm probably consuming a little bit higher than that. Now, not only does Garth have substantial research experience, he's also very active with outreach, sharing his research with children of all ages. He was awarded the best talk at a scientific meeting in Russia of the North Pacific Marine Science Organization. And I'd like to say thank you to Garth for his efforts here, because as we know, education is an essential part of effecting social change for the benefit of our environment. So thank you so much, Garth, for your investment in our environment and for coming tonight to share your information with us.
Thank you, Sandra. I don't think I've had such a nice introduction before. I feel a little bit nervous now. I feel like I have big boots to fill.
Well,
I guess
you're deserving of it.
they're my own boots, but uh, all right. So hi, everyone. It's a pleasure to be with you this evening. You know, a little weird to be sitting here on the other side of a computer screen. I normally like doing these things in person, but we're going to go with it, and yeah, we'll hopefully have a nice time tonight. As Sandra mentioned, I'm a PhD candidate at the University of Victoria. I actually did my undergrad at UBC in Vancouver. I saw at least one actually friend from my UBC days who is watching today. And so I'm in my final year, I guess. In your PhD, you can kind of take however long you need to take until they boot you out after around 7 years, but I'm only about 5 years in and I should be finished soon. So I will be leaving and not actually kicked out, which is always nice. And so, yeah, I will start with, and also I have my contact down here. If anyone wants to get in touch with me, I've got my email down here, as well as my Twitter handle is just G Covernton. So super easy. Feel free to tweet at me or like me or whatever Twitter things you do. So yeah, I'm going to be talking to you a little bit about some background, including some of my own research on what we know about microplastics, what we don't know. This is a really complicated field, so I'm going to show you some of the complexities of the study and why, maybe what you might read in the media may maybe be a little overblown or a little bold given the sort of uncertainties that exist, but also kind of where we're going and what we need to do. So, there we go. Okay, so just as a broad outline, I'm going to start with an introduction to my own work and kind of what I've been working on. I'll talk to you a little bit about society and plastics and our history of using plastic. I'm going to talk about microplastics, what they are and how we study them, specifically how I study them. I'll talk about the effects of microplastics on animals and a little bit about humans, kind of what we know. And then I'll talk about human exposure to microplastics, mostly with that study that Sandra mentioned in the intro, actually, which I was a co-author on. And so I'll go dive a little bit into that study. And then I'll also talk kind of about broader what we can do as a society and as individuals to combat this problem. Okay, so just an overview, I guess, of my work on microplastics. I've done some other things here and there. My background's in ecology, so I always like to link these things to ecology and what it means for ecology. Specifically lately, that has been food webs. So I've published a bit on sampling methods for collecting microplastics in the environment, on bivalves, and I'll talk a little bit about that research as well in relation to shellfish aquaculture, with actually some work up near Campbell River on Quadra Island, as well as some other places around the island. And then this human consumption of microplastics paper, which I'll discuss, as well as more recently, I've been really interested in microplastics and food webs. And so I have been working on studying, and I'll talk a little bit about where this is going, but basically looking at a food web and using some methods from ecology to track microplastics in that food web and figure out how many there are, depending on where these animals are feeding in a food web, so how high up they are. For biologists in the room, that's known as their trophic position. So I guess just first of all, I'll start off by explaining to you about plastics and our history of using it as a society. So plastics really are a pretty new invention. They really took off. They've been around since the early 1900s in small amounts of production, but after 1950, after the Second World War, they really kicked off. It took a little while for them to take off. This is a plot down here of the plastic production thus far, and then an extrapolation based into the future, based on trends and past trends. And so since 1950, there really was this kind of slow growth, but then as an exponential curve does, it really took off after 1970 and through the 80s and 90s. And then this number here goes up to, I believe, 2013, where we reached 311 million metric tons of plastic being produced every year. And if we keep going on this way, and thus far we don't really have any signs of slowing down, we're looking at around 1.8 billion metric tons of plastic being produced every year by the year 2050. And this part up here, this map, just kind of shows some of those primary producers of plastics. So North America, especially the US and China, as well as Europe and the rest of Asia, are the biggest manufacturers of plastic. So of all this plastic that has ever been produced, there's a really great study from Geyer et al. That came out in Science Advances in 2017. And they did a great overview of basically trying to figure out how much plastic we've made basically all time. And by all time, they defined it as 1950 to 2015. And they estimated that we had produced around 8.3 billion metric tons of plastic since 1950. Of that 8.3 billion, there was about 2.5 billion still in use. So kind of like in construction, building materials, things that haven't been thrown away yet. And then really, when you look at all that stuff that's been made, a large proportion of it has been either discarded, incinerated, or recycled. And so almost 80%, so 79% has basically just been thrown away into landfills or the natural environment. About 12% has been burned, and then about 9% has been recycled. And unfortunately, only 0.9% of that total production has been recycled more than one time. So it means every time something's going through the cycle, it basically only has about a 10% of going back into the recycling stream, a 10% chance. And so it means that less than 1% of plastics we ever make are actually being recycled more than one time. So this really is just a linear economy where we're making these plastics and then we're eventually throwing them away. They just don't stay in the recycling stream. And in terms of what this plastic looks like, all these plastics we're making, a large amount of this is plastic packaging. So it accounts for over 50% of global plastic production at about 141 million metric tons per year in terms of plastic waste, sorry. And other sectors in textiles come close second in terms of plastic waste production. And actually in Canada, we're sort of similar to global stats in that about a third of the plastics we use in Canada are single-use or short-lived products that are going to get thrown away. I'm not sure what that makes up in terms of our waste, but that's just in our general use. About a third of what we use is just this single-use stuff that maybe is potentially unnecessary and is just generating like a large amount of waste. And we'll come back to this later and why this is important. And it fits as well into some of the regulations in Canada in terms of starting to ban some of these single-use products. And in Canada, we're also not better than the worldwide stats in that we only recycle less than 10% of all of our plastic waste. So again, we are just not very good in Canada either at doing this. But when we talk about plastic, it's not just one thing. There are a lot of different types of plastic out there. And so what you might be familiar with are those numbers that occur on the bottom of plastic bottles and other things. And that often refers to the type of polymer and whether it can be recycled. And I actually didn't know this super well, but there's a couple of deep dives out there that have come out recently. I heard a good one, I think, on NPR, and there's been some other longer form stories about how this was actually mostly just a complete marketing mechanism by the industry to convince people that plastics were good because they could recycle them with these nice numbers. And actually a lot of recyclers were really surprised and confused when these numbers showed up because they were essentially useless to them. And some of the things that were being claimed to be recyclable, according to these numbers, people in the industry have said, well, that's actually not recyclable. So it was pretty much a greenwashing strategy that worked pretty well because people, if you think of through the 90s and things, just the idea of recycling became so popular and so much of that was driven by the industry. But really, when we're talking about plastics, the most common ones that you're going to see the most, especially just in your day-to-day use, are polyethylene, polypropylene, and polystyrene. So polyethylene, there can be high and low density polyethylene. The low density stuff is often things like plastic bags, like those thin filmy plastics. And then high density would be like sturdier storage containers and other strong items like that. Polypropylene is common in food. It's usually rated food safe, so a lot of food packaging and things are polypropylene. Things like bottle caps, also rope. Polystyrene you're going to be familiar with in terms of those throwaway takeout utensils, as well as styrofoam is also just foamed expanded polystyrene. And then there's all these other ones out here. So you might recognize something like polyester is very common in your clothing, as well as drink bottles like PET, which actually is a type of polyester, I believe. Acrylic is used in paints as well as in clothes, and then there's nylon in clothes as well, which I don't even think is up here. And then a few various other ones. PVC is another one you might recognize from like plumbing pipes and things like that. But what's really interesting is when you compare to the types of microplastic debris that are found out in the environment, it matches pretty closely with the predominance of them match quite closely with the actual materials. So you can kind of see they're reflected just in what turns up in the environment. Okay, but what are microplastics? So when we define microplastics in this as scientists, there's a little bit of a debate sometimes about this, but the most common thing I would go with is a tiny little plastic particle that's less than 5 millimeters in its longest dimension. And so that's about the size of a grain of rice or the eraser on the end of a pencil. So like pretty small, something you can just see with your eye, and then all the way down to around 1 micron, which is something much that you're going to need a microscope to see, and maybe even a scanning electron microscope. So things that are very microscopic down to that point. And then it comes in all different materials, shapes, colors, and sizes, as well as different sources. And they really do show up everywhere we look in the environment. I have yet to see a paper published anywhere that really finds no microplastics. And if they do claim to find no microplastics, it's usually because their methods were a little bit flawed, I guess. And it's really only, this research really only kicked off around 10 to 15 years ago. So in 2004, he's often called the godfather of microplastics. I actually watched a talk for him just the other day, and it was really great. But his name is Richard Thompson, and he's at the University of Plymouth in the UK, and he coined this term microplastics back in 2004 in this fundamental science paper. It was in the journal Science, so a big paper that came out, and I believe it was called Lost at Sea, Where is All the Plastic? And he was kind of saying all the plastic that we're seeing, we're kind of missing this mass balance in terms of all this floating plastic. It's not as much as we think it should be. And so this was the initial claim that, well, a lot of that is fragmenting and getting smaller and becoming these microplastics. So since then, though, it was a bit of a slow start, but then we saw around 2012, 2013, things starting to go into this exponential growth in terms of number of publications coming out. In 2019 and 2020, we're way up off these charts here. So now we're looking at, I check in and collect these publications, and I have many thousands now of papers in my library because they're just getting published. There's generally at least like a paper coming out a day pretty much, if not more, probably 2 a day. And so we can divide microplastics up into 2 main categories. So they're the primary microplastics, meaning they're produced to be small. So that can include things like the infamous microbead you're probably aware of that was being put into cosmetics, has been banned in Canada, but only in rinse-off products. So it can actually still go into things like sunscreen, which are not rinse-off products, as well as just any kind of small plastic bead. So these kind of polypropylene ones might be used to stuff like a teddy bear or something. And then nurdles down here are these primary production pellets, and they tend to show up on beaches a lot, actually. And so there is, for example, there's some librarians at UVic who actually track these things and go out and they have maps of where they wash up around Victoria and think that they're probably coming from a plastics production facility, I think over in Vancouver. But essentially what they are these little bits of pure plastic that get shipped around. So a manufacturer will make these little pellets and send them off to someone who's making a plastic product, and then they'll mix and match the polymers that they want and melt those down to make the final product. But they can get lost in transport or when they're cleaning equipment in the factory. And so there have been some calls for like better regulations of these. But anyway, so nurdles are another kind of larger microplastic that might show up on shores. The secondary microplastics, though, are by and large the highest sort of, or the most common type of microplastics that we find in the environment. Primary we do see, but just like really when we're looking out there in animals and in the environment, we really see these secondary dominating. And so this can be things like textile fibers. I have some pictures up here because this is what I commonly find in my seawater and animal samples around Vancouver Island. And so these can be things like polyester fibers and nylon fibers, probably coming out of our clothes when we're washing them and then going into the ocean. It can also, secondary microplastics though, can also be any sort of bits that can be degraded from larger plastic items. So as the sun beats down on them, as the waves bash them around, they can, and even as animals start taking chunks out of them, they can fragment and get smaller and smaller and become these secondary microplastics. Could also be things like car tires. It's sort of, sometimes people debate whether these should be called microplastics because the synthetic rubbers, I think, it's still debatable about whether or not they could be classified as plastic, but these synthetic rubbers are also a big source of what some people call microplastics in the environment, and often the tire crumb that comes off of them can have a lot of really toxic chemicals associated with it. So just the car tires degrading can also be a big source of these microplastics in the environment. And as I mentioned, there's a bunch of different ways these things can go into the environment. We often have a focus, we think about the ocean often in these conversations, and I think that's very often just because of who has been doing this research so far, but really they are everywhere. And so they can go into the atmosphere, they can get blown through the wind and the rain, deposited into soils on land. They can directly get dumped, although hopefully this is not happening super a lot. And once they're in the atmosphere or going into rivers and lakes and things like that, they will eventually find their way into the ocean or get deposited into sediment in rivers and lakes. But also they can find their way back to us, right? And maybe not even that far away from us, because we are the people who are using a lot of these plastics. So actually our own home environments tend to be the most contaminated environments out of everywhere we look, just because of the number of little fibers of things blowing around in our air and settling under our food and things like that. But it is this complex cycle, and I've heard people almost start to call this like the global geoplastic cycle or something. Like they're basically part of this big global cycling now of microplastics. And you probably have also heard about this. I remember when I first started giving these talks, this used to blow people's minds, but recently it doesn't anymore because I think people just know this now. But when you're washing your plastic clothing, so things like acrylic, polyester, nylon, these are all forms of plastic, and they can release millions of fibers just in a single load of laundry. So this study back in 2016 found that when you wash these different sweaters, you could get around 500 to 700,000 per wash per sweater for an acrylic sweater up here and then a polyester sweater over there, the green one. So this is another really big source. And for example, in Victoria, we still don't yet have sewage treatment. So these are pretty much directly going into the ocean here, although that will change soon. And so sewage treatment can be somewhat effective at removing these. A lot of studies find they're maybe 90 to 99% effective at removing these microfibers out of the sewage that is coming from washing our clothes, well, just in the sewage in general, I guess. But the thing is, when you're talking about millions and billions of these fibers going in perhaps per day, even a 1 to 10% release could still be a substantial amount of these fibers, right? And these microplastics. And the other thing is that when it's filtered out, that stuff has to go somewhere. So often in sewage, they'll have like a settling pond and settle down some of this sludge. But that sludge usually gets then put onto land. Sometimes it's used in like fertilizer and farming. And so then that actually can become another source of microplastics to the environment, when then the rains and the winds can wash those microplastics out of the land and perhaps back out to rivers and oceans and things. So really just the sewage treatment may not just be the answer we would like it to be, I guess. But once, from an ocean standpoint, once microplastics are in there, they can really be moved around quite a lot by currents. We're finding them showing up in much higher than expected concentrations in the Arctic. So this is a heat map kind of showing from very low amounts of plastic up to really high amounts of microplastic, sort of global modeling study here. And you can see, you probably heard of the North Pacific garbage patch over here. So this North Pacific gyre circles around here between Asia and North America. And what happens is it kind of creates a dead zone in the middle. So materials will just sort of start to settle there. Fortunately, kind of it's also a pretty dead zone. It's very nutrient poor, so there's not a ton of marine life there, which is maybe good because that's where the most plastic is. But it is very interesting, and it is, when you do these modeling, you can see this is probably the darkest spot on this map is right in that North Pacific Gyre where the Great Pacific Garbage Patch is. But a lesser known fact that people don't always realize is that we have a bunch of these gyres around the world. So, you know, there's one in the Indian Ocean, there's one in the South Pacific, North and South Atlantic as well. And so we can actually see these accumulation zones showing up in other parts of the world, often right in the middle of our ocean there. Another factor in how this plastic gets transported around the globe is its density. And so just a quick science review, you might remember that's basically just for a given volume of something, you know, what is its mass essentially? And so in this case, I'm measuring it as gram per cubic centimeter, which is the same as gram per milliliter. So you can kind of think of it loosely of how heavy something is. So seawater is around, it has a density of around 1.027 grams per cubic centimeter. And these plastics can actually range from being less dense to more dense than seawater. So some things like those low and high density polyethylenes are going to be lighter, and those are going to float on top of the water. But there are other things like, for example, like PET and PVC that are heavier than seawater, and so those will sink. And that applies for microplastics as well, although some of the fluid dynamics can be more complicated at these smaller scales. So some of them might still be transported pretty far long distances. But the other kind of interesting thing is even for those floating plastics, over time they can actually get colonized by a bunch of microbes and algae and all these other little things growing on it. They can even get eaten by an animal and pooped out and covered in their feces. And so that can cause it to start sinking, and people have demonstrated this in the lab and also actually witness it in the field. And you can see microplastics that'll almost like go down and basically what they call marine snow. So it's just all this like stuff just like sinking down to the bottom of the ocean. And from there, it might not necessarily stay there. We are starting to think that a lot of microplastic over time will deposit the bottom of the ocean and remain there, but some of it will definitely get resuspended. Organisms maybe will feed on the biofilm on that plastic, and then it could pop back up. So there's probably this cycling going on in the ocean where things are not necessarily just staying in one part of the ocean. People used to pretty much only sample the surface, thinking, oh, all the microplastics would just be floating there. But over time, people have started looking more at different depths, and they do find those microplastics pretty much everywhere throughout the water column in the ocean. So they can really move up and down a lot. And so, of course, when these things are in so many environments and in the ocean, we do find that there are a large number of animals where they show up in their bodies. Now, these aren't necessarily very high numbers that we're finding. A lot of reports are really only a few microplastic particles per individual. So we're still kind of figuring out, and I'll talk a bit about this more later, but like what that actually means for exposure. But we do find them in, in sea turtles, in sea stars, in sponges even, in different marine fishes, and even in our big charismatic megafauna, like our humpback whales. And I believe I even saw at a conference recently, someone's talking about them in killer whale poo. So yeah, they can kind of show up everywhere we look in animals. Another interesting element, and I alluded to this earlier, but there's things that will grow on this plastic. And so researchers have started kind of calling this the plastosphere. And so in this picture over here, you can see this is a really close-up shot of the surface of a little bit of plastic. And you can see these little microbes colonizing the surface, and they can do all sort of interesting things. And people find when they compare those microbes living on plastics to the microbes free living in just the seawater or on other more degradable things, they find a distinct community living on that plastic, which is quite fascinating. And so there is some thought about, well, are these microbes potentially more harmful? Is there also a linkage to animals eating plastics and encountering potentially harmful microbes? There has been shown to be more algae that might cause disease, for example, on microplastics, or even actually like more antibiotic resistant bacteria sometimes have been found to be on plastics. So could they also maybe be a vector, passing these antibiotic resistant bacteria through the environment? And we don't really know yet. The other thing is they can actually, because of these algae on them, there was one study a while back that showed that the plastic will start to emit this smell, and it's a compound, it's a sulfur, I believe it's called DHS, but it's basically as the algae is decomposing, it releases this thing that smells good to seabirds. And so in some cases, because microbes love to hang out on the plastic so much, it might start to smell like a really tasty piece of food for some animals, and they might end up being more attracted to that plastic than to other things. So this is kind of what we know about where they go in the environment and how they move around, but how do we actually study these? So when we go and we get samples, when I go and I get clams or oysters or fish, I have to find a way to get those plastics out of that animal, and it's not that easy, let me tell you. So you have a complex sample, whether it's sediment, so it's sandy and muddy, or you have an animal with fat and tissue, and you have to get these tiny, tiny microscopic particles out of it. And so the way we tend to do it, there's usually a number of phases. So you start with your sample, whatever it is. There's usually a digestion phase where you're starting to remove some of the other organic materials, like the biological materials. I tend to use potassium hydroxide, which is a strong base, and it's just gonna basically degrade out all the biological material. There's usually some kind of concentration and separation. I would put the separation generally before the concentration phase here. Although you would actually know, I would do concentration, separate, and then concentrate again. But that's overly complicated. But essentially, the separation phase can be using a density separation. So using like a highly saturated salt solution to make a heavy solution that's going to float out plastic, but allow all the sand and other things to sink to the bottom. And then usually it'll be concentrated and filtered onto like a little filter or something that we can then image and look for these microplastics, count them, look at their size, and then ideally do some chemical identification, which is really the standard for the field these days. Folks used to publish and say, oh, we think this is microplastic, but that's becoming more unacceptable these days because there are so many things that could look like plastic and not be. So often we'll do different things like FTIR and Raman are two different types of spectroscopy. I'll talk about those a bit later. But they're like these forensic methods for IDing the types of particles. And there's also ways people are starting to burn their samples and look at the chemicals coming out of that. And so there's a number of different more and more technical ways people are starting to analyze these plastics and figure out what they are or if they are indeed plastics. So I mentioned the chemical digestion. I tend to use this potassium hydroxide. And so we'll take something like a sea cucumber here and take its digestive tract out and digest it down and then filter it. It turns into this brown goo here and then suck it through this filter here. And we have to be really careful in the lab. Actually, it's kind of funny. We basically have to fight plastic with plastic, which is a little bit unfortunate, but we just don't really have a better material right now. And so for example, by wearing these yellow banana suits, I like to call them, they're basically these yellow Tyvek chemical suits. And they're nice because they don't really shed, but they cover up our clothes so that our clothes aren't releasing any fibers, and then anything stuck, there's nothing like stuck to our bodies that's gonna float off. We work in this thing which is called an laminar flow hood, which is positively pressured. So it's gonna blow air basically in our faces to keep things from falling in and settling on our samples. And then also I run air filters in the room. We clean a lot. And then I also analyze my samples on a microscope that's covered with this taped down plastic garbage bag. And that's gonna keep particles also from settling down. And then we also run controls to check for background contamination to make sure what we're seeing is actually in our sample. Then we'd also, then we'll use a microscope to ID these things. And so, and this is kind of, this is what I tend to do anyway. Like some people are starting to move to more fancy analytical procedures, which are more maybe automated and can find smaller plastics. This method of trying to look for things, we're often limited to about 100 microns, which is about a 1/10 of a millimeter. So still quite small, but there are microplastics much smaller than that that require much more technical methods to look at. But these ones that I am looking at, we often kind of look at it and we have, for example, this is what we would go through for fibers to try to figure out, is this something that could be a microplastic? And if it starts to meet some of these definitions, then I'll say this is a potential microplastic, and we'll get our tiny, tiny little tweezers and pick it up and move it over onto a double-sided sticky tape and store it for the chemical analysis. So what that looks like is you basically end up with this, this double-sided sticky tape circle on a circle of transparency here. And each of these little dots here is actually a tiny little potential microplastic fiber. And you actually can't even see any of them. They're so tiny and microscopic, but I guarantee you, we picked up each of those little things with tiny tweezers and put them there. And then for these particular samples, I actually analyzed them in a lab at the University of Toronto with Dr. Chelsea Brockman last year in the fall, who I'll ideally be working with next year as a postdoc researcher. But her lab they now actually have a bunch of different things. But the machine that I was using is this thing, which is a Raman spectrometer. And basically, it's a fancy high-tech microscope that actually shoots a laser at that tiny little particle. And then it can use how the laser light is interacting, how it's exciting the molecules within that material to then give you like a nice readout on your computer that you can compare with a library to try to figure out what type of plastic or if that particle is in fact plastic. And it's really quite cool. It's like this tiny microscopic laser, and you have a little joystick. You can see it down here where you're moving it around to line up this laser. So it's kind of fun, although by the time you're doing 1,000 particles, it becomes kind of monotonous. Okay, so that is how we study microplastics. And now I'm going to kind of talk about a bit about what we know about their effects and what we really know about them and what we really don't know. So one of the things that makes these things so hard to study, microplastics are a complex contaminant. I really like this paper that came from Chelsea Brockman in her lab, where the opening line was microplastics are not microplastics are not microplastics. And what they really meant is like, we say microplastics, but we mean so many different things, because we can have all these different types of polymers. They can all have different additives in them. So there are other potentially toxic chemicals, plasticizers and flame retardants and UV stabilizers that get added to plastic. They can be in all different product types and different mixes of polymers. And then once they're degrading, they can become all these different sizes and shapes. And each of these things will interact with an animal and be toxic in completely different ways, or not toxic, right? So if a particle is big enough, maybe an animal can't even ingest it. And so when we talk about microplastics, there's so much more going on behind the scenes there. And this is one of the reasons we have so little information about how really toxic the microplastics in our environment are right now, is because they're so complicated and so hard to study in the lab. And often researchers, unfortunately, are limited. They'll test one type of plastic with in a certain size range, and then they tend to, at least more traditionally, just use a really high dose to see what will happen. But in often cases, it's orders of magnitude higher than what actually occurs in the environment. So we kind of end up in a situation where we still don't actually know what's happening in the environment. But the potential ways they could cause toxic outcomes is releasing chemicals. So there's monomers, which are like the constituents of the plastics themselves. So these residual building blocks of the plastic. There's other additives that are in there. They could also perhaps concentrate pollutants from the environment, although honestly, I would almost scratch this one out now, because a lot of the work, the modeling work coming out of especially the Netherlands, shows that the role of microplastics in terms of transferring other chemicals from the environment is very, very minimal, if at all. And if there was enough microplastic, they might actually act more of like a sponge and take toxins out of an animal, which is quite fascinating. So this thing, in terms, the environment tends to already be so polluted that the microplastics don't really actually seem to make much of a difference being out there in terms of the pollutants already out there. But then there's also the physical outcomes. So if there's enough of them, they could potentially give a false feeling of fullness to an animal. And then if they're small enough, they might be able to translocate or move out of the digestive tract and into other parts of the tissues and bodies of animals and cause issues there. And so then when we think about these toxic outcomes, we also have to think about like a bunch of different scales. So I love, as an ecologist, to think about the idea of scale, and meaning, how zoomed in are we to something, right? And so we can zoom all the way in to like smaller than a cell and the way that chemicals are interacting, or we can zoom all the way out to like what's happening at the ecosystem, the population level, meaning overall, like how many animals are there out there and how healthy are they? And so the microplastics can act at a bunch of these different levels once they're ingested on the organism level, but then also these can scale up to these more complicated things that are much harder to study. And as I mentioned, most studies, they tend to use these pristine microplastics, so ones that haven't been weathered and aged in the environment. They tend to use overly high doses, although this is starting to change a little bit in the literature. And so we just don't really have enough information to figure out the true risk. So yeah, to separate out, I like to always separate out the idea where hazard is the potential for something to cause harm to an animal or to humans, and risk is the actual likelihood of that harm occurring. But in order to get from hazard to risk, you have to first go through dose and exposure, so how much is being exposed and for how long, right? And so the problem is that we have some information about hazard, but it's probably usually with an overblown exposure. And so we don't actually yet know, based on those hazards that we see, you know, how does that translate into real risk based on what's out there. And so the one thing I think is interesting is there are some studies showing that you can get these little bits of plastic, these guys over here, showing up in these cross sections of fish livers. So we know that they can potentially go into animals, and then I sort of wonder, we still don't know how much they might accumulate there and potentially cause more chronic harm over time. And so that's kind of a in progress research for people. The other issue is that we just don't have good evidence about the really small stuff. So all those methods I was talking about earlier are really only good for at least 1 micron microplastics, and often actually like around 100 micron microplastics. They just get so challenging as they get smaller to study. And we have these actually submicron and nanoplastics that are even smaller. And we just have we actually have no idea how many of these are even in the environment because they're so hard to separate. We just don't have methods yet for separating them from environmental samples. And these are the ones that actually might be more toxic and have more potential to be toxic. And so while I think the evidence for the harm of current levels of microplastics in this range is kind of tenuous and we don't really know, I think this is probably over here where a lot of that toxic harm might actually happen, and we just have no idea because we don't know how much of those are out there. So it is really early days in this field for understanding these things. But humans are also exposed to these things. So as Sandra mentioned in the intro, I've done some work on this. And so one of the projects I worked on was looking at microplastics in farmed BC shellfish. We had a bunch of sites here around Vancouver Island. So like this is around Quadra Island up here in the Discovery Islands and Oak River Inlet, and then some kind of on the west coast of Vancouver Island over here, and then further down the Georgia Strait. But basically, when we were looking, I looked at shellfish that I cultured, so these manila clams and Pacific oysters, both on and off shellfish farms, to see if there was any difference where they're based on where they were grown. And overall, I really only found less than 1 particle on average showing up in a shellfish. So the concentration was quite low, and mostly seemed to be textile fibers that were already circulating in the environment, and not so much any like plastic equipment that shellfish farmers might have been using. That didn't seem to be an issue in that case. And it really suggested that, you know, while we might hear a lot about shellfish being this big source of microplastics in the news and things like that, they actually really aren't probably. And, you know, they're a small part of our diet, and the concentration of them is so low that you should definitely still keep eating shellfish. The health benefits, I would say, definitely outweigh the risk. And there's actually a lot of cool work coming from this researcher, Evan Ward, in the States. And he does a lot of work and shows that oysters and mussels and things are actually really, really good at isolating these microplastics and booting them out of their system before they even eat them. So it's not like they're just passively taking up everything in the environment. And then another thing to consider when we're thinking about microplastics in our seafood is that there's some results showing that there's actually our exposure risk is probably much higher just from while we're cooking our food and while it's sitting out on our dinner table than actually what's coming in from the environment. So if I were to extrapolate my results on shellfish, I could estimate maybe the average person would eat around 87 particles per person per year. But there was a study in the UK which had about 123 particles per person per year, which is really nice. It's nice when other researchers have numbers that are close to your own. So yeah, maybe we have about 100 particles per year. But they just looked at how much could be landing on a dinner plate and found that if you account for that, then just from what's floating out during dinner time, you could be taking in around upwards of 4,000 particles per person per year. Oh no, sorry. That's where people, sorry, I mixed that up here. 4,600 is in countries where people eat more shellfish. So maybe if shellfish was a higher proportion of your diet, maybe you're in the thousands. But even then we're looking up at about 13, this is actually Oh, why does this number look so weird? I think that's maybe a typo. I think it was 13. I think that was potentially supposed to be 13,000 particles that could just go onto a meal from dust. And so that, oh, I see. Sorry, never mind. That dash is confusing me myself. So 13 to 68,000 particles per person per year that could just be settling onto a dinner plate. So way more, like orders of magnitude higher than what would be coming in from that seafood. And that's just from having our synthetic carpets and our clothings and all the plastic things in our environment. And so there's also not just the direct, consumption of microplastics in an environment and then going to us that way. There's a ton of other ways that microplastics could get into our bodies. So they could come out of plastic packaging, which is a source we're just starting to explore in more detail. They could settle during a mealtime, as I mentioned, but they could also get in there during factory processing and contamination during transport, et cetera. And so in the study last year on human consumption of microplastics, I talked about a bit earlier, what we did is we looked at 26 studies globally. We looked at microplastic concentrations within foods, beverages, and air. We looked at the microplastic characteristics, and we ended up with 402 data points over 3,600 processed samples across these studies. And then we looked at the recommended intake for Americans, just because this was really readily available information. From the USDA, the US Department of Health and Human Services, and some other folks. And we separated out based on sex, like children and adults, and then men and women, just because that's how they divided their categories there. And what we did was we took those microplastic concentrations in different food sources and multiplied by the recommended consumption, and then you get an estimate for yearly microplastic consumption. And what this looks like is when we tally these up, we mentioned this at the beginning, we could have up to around 50,000 particles per person per year coming from food and drinking water. But really what stood out was if you account for the inhalation via air, you could be taking in a lot more. Up to 74 to 122,000 per year when you add in the inhalation factor. And so this is only accounting for about 15% of our caloric intake, and we're really missing data, a lot of data still on red meat, poultry, dairy, grains, fruits, and vegetables. And actually extrapolating, a researcher, Stephanie Wright in the UK, extrapolated from a study of human stool that came out in Austria earlier this year or last year, and estimated around 29,000 to 1.5 million particles per person per year based on what was showing up in the stool. But they only looked at about 8 people, so those numbers are very preliminary, but it kind of suggests that, well, yeah, like the numbers are a lot higher than we estimated, and that's probably because we only accounted for a small amount of these calories. And then also when you look predominantly in the studies, they do seem to be fibers showing up, but I also think in part that's because these are, again, those larger size fraction of microplastics, which especially in our homes and things like that tend to be fibers. When you go into the smaller range where we're not really measuring yet, it's going to be more fragments. So that's, I think those numbers are really going to get boosted up as we start going smaller and smaller. So should you be worried at this point? Well, I think with many things in science and in general, it kind of depends, and the answer is maybe. There's no smoking gun yet. There's no direct linkage between, oh, we're eating all this plastic and there's this impact on our health. We don't really, as I mentioned earlier, understand that linkage between the hazard and exposure, and so we don't understand the risk. The doses that are estimated right now, it's still pretty low when we consider how many other pollutants and things we're exposed to. So I think it's still early days, but if there are negative effects, it's going to be probably more of a long-term thing. And for example, I would probably guess that something like smoking cigarettes is going to be much worse for you in the long term. But I think at the same time, based on what we know it's in there and it's going in our diet. So I do think we need to take some precautionary steps to reduce our exposure to microplastics and to try to cut back on our plastics usage in general. It's kind of balancing my worry as an environmentalist with my skepticism as like a good scientist. But regardless, I think, yeah, we can definitely take measures now. We don't need to know how bad these things are right now. We know enough to say that they could be bad, so we do need to start protecting ourselves and wildlife and using less plastic. And so this is kind of the sort of what can you do happier note I'd like to end on, and I'm getting close to wrapping up here. But the best things we can do as personal consumers is to just avoid or reuse plastic, avoiding these single-use items, you know, these ones that will actually, a lot of these are likely to be banned in Canada in the next couple years now. And then also just thinking about some of these, I've seen them termed like stealth microplastics. So things that you might not even think about. So things like your car tire, there's not much we can do about that. I mean, I don't know of any natural rubber car tires you can get, but so although I did see some students, I believe in the UK or something, invented this device that could attach to a car tire and collect all the debris over time. So I mean, who knows? Maybe cars will start coming with these things or something. But there are other things you can avoid, like glitter tends to just be tiny bits of plastic. So looking for natural glitter if you need glitter. Our clothes, you know, washing our clothes, not super as much as we don't need to wash them every time we wear them. We can potentially switch to other materials, although I don't necessarily recommend just buying new cotton or wool stuff because that can also be really bad for the environment. So I like to try to get secondhand natural materials where I can and minimize my synthetics, and then especially try to not wash those as much. And if you do wash them, if you use cold water, if you use liquid detergent, they release less microfibers. I believe also a front-loading washing machine releases less microfibers, and you can actually also now buy filters that will attach onto your washing machine. So stopping these things in our homes is probably a better solution than just treating our sewage. Other things like plastic scrubbers and AstroSurf, so just looking around, you know, what are these things and are they degrading over time and are they producing these microplastics? The other thing to be aware of is the sort of controversy over biodegradable plastics. This is again a bit of greenwashing. So words like bioplastics, biodegradable, and compostable get thrown around. But often bioplastics just means it's made from plant material. So you can make traditional plastics out of corn or plants. And so that just because it's called bioplastic doesn't make it better than traditional plastic. Biodegradable may not mean compostable or may not even actually mean biodegradable. This could just be like a catchy word that people use, but it might just have an additive into it that basically just causes it to just become microplastics in the environment. Compostable plastics don't decompose outside of an industrial composting facility, so not in the ocean and not in your backyard compost. So even if it has this nice BPI label here that, for example, the city of Victoria recommends for compostable plastics, I have heard that even going to some of our industrial composting facilities here, things will often get just pulled out and landfilled because they just don't break down fast enough. And so I got this quote from the Globe and Mail from an article a couple years ago where at that point, out of the 200 industrial composting facilities in Canada, about 40 of them were only 40 of them were accepting certified compostable bags for processing. So these things, especially like the bigger stuff, it just takes so long to break down that after a few cycles through the system, they're just going to pull it out and landfill it. So it's really not necessarily that much better than just regular plastic. So better to avoid plastic in general. We also need to read our labels. I mentioned this, so just be aware of like what is in your clothing, what is in your products, like when is something plastic. After a few years ago now, I'm just more aware of like what are my clothes made out of. There are some materials alternatives. So there's like rayon is semi-synthetic. It's often shows up in ocean samples though, even though it may biodegrade. And the other thing is that rayon is really chemically intensive to make. And there's a lot of issues with it being made in developing countries and with workers and working in really poor conditions being exposed to really toxic chemicals. Tencel, I think that should say Tencel, is also a semi-synthetic that I believe does biodegrade in the ocean and could be better. I think it could have some environmental issues though, but there are some companies starting to work on these maybe better semi-thin synthetic, and by that I mean it's made out of like cellulose or plant material, and then it's like modified chemically. And the other great thing you can do is just cleaning up beaches. This was back in 2015 on the north end of Vancouver Island, and when we pulled up a lot of this debris. And so this is a great way to get out and in your community, and every bit of plastic you take off a beach is one less microplastic source in the environment. And even when you're just walking on the beach, just grabbing some plastic, sticking it in your pocket, you know, and going on through your day. And unfortunately, the best thing we can do right now is put those into the garbage, but it's a good thing to do, and you're gonna cause conversations to happen. The other thing is just being aware that, and not being too overwhelmed, but at the same time realizing that this is really a global action, a global effort that is needed. There was this 2 really great studies that just came out like a few weeks ago in the journal Science, literally in the same issue, and they both found very similar findings, which were that looking at this, if we keep going business as usual, our plastics emissions are going to keep going up. So we're going to be looking at over here, I'll read this quote. We implementing all feasible interventions reduce plastic pollution by 40% from 2016 rates and 78% relative to business as usual in 2040. So even with immediate and concerted action, 710 million metric tons of plastic waste cumulatively entered aquatic and terrestrial ecosystems. And the other authors, Burrell down here, found similar results where even if we take drastic measures now, we're still looking at a really huge amount of plastic just going into the environment just based on that ever increasing plastic production that we're doing. And I like their quote here: to reduce emissions to a level well below this prediction, extraordinary efforts to transform the global plastics economy are needed. So we need major action. This is far beyond what you can do as an individual. We need major government action on this. We need way better recycling. We need way better materials. And we need massive reduction in production. If we're gonna have any reduction in plastic waste, this is our target here, and this is where we would hope to go. But even under the most ambitious scenario, they calculated that we're probably still looking at an increase in plastic waste going into the environment by 2030. So this is really alarming, and we need to act now. And so we need both these individual actions of your own footprint on plastic and your votes and increase in awareness, but we also do really need these shifts in societal norms. We need government regulation. We need standards for compostable waste. We need to phase out certain products, as Canada is starting to do with the single-use plastics legislature. And then we also need to incentivize recycling and better technologies, because right now recycling is often not profitable. So BC, for example, is doing some of this with extended producer responsibility, and we need way more of that. And I like this, so Richard Thompson, who I mentioned earlier in his talks, likes to say that plastics aren't the problem, it's how we use them, how we design, use them, and dispose of them that is the problem. And I really like that, because plastics are really a wonderful material. They're lightweight, they extend the shelf life of things, they save lives by being these sterile medical equipment, they're cheap to produce. They make airplanes lighter and cars, they reduce our carbon footprint that way. So they can be an amazing material, but right now we're being so irresponsible with the use of them. And so it's really about the design process. We need to design them to be recyclable. We need to only use them when we need them, and we need to dispose of them properly and keep them in our economy and not just going to a landfill or the environment. And so I always like to close with this sort of hopeful idea of this circular economy, where we reuse and we repair, we recycle, and we don't let things end up just going back out of our economy. We keep them cycling. And so hopefully we can work towards this together. Okay, so I will end there and go to questions, I guess. Sandra, I don't know if you want to come back in here. Got our chats here. Just gonna pull up the chat. Okay, there's a lot here. Start working through this. Okay. Oh yeah, there's one comment here about milk in glass bottles that are recycled and reused. I really like that. Yeah, and I think there's a lot of cases like this where just historically we actually had potentially better systems of doing these things. And for companies, a lot of cases, I think they probably liked going away from that sort of thing because it was cheaper for them, and they could just send you these throwaway things. But yeah, it would be really nice to go back to something like that.
So thanks, Garth. I'm just unmuted now. You can hear me all right?
Yep.
Yeah. So thank you so much. That was just absolutely fabulous. I learned so much. I think we see lots of virtual applause happening over there in the chat. So we had lots of fun. The questions came only at the end. If you try to like sift through that chat, you're going to be a little bit busy. So first, I just want to note that we do have 2 beach cleanups coming. So if anybody hasn't been looking at the chat, at the very bottom of the chat, thank you to Naomi for giving really specific details about beach cleanups happening very soon. So one on Saturday, this Saturday, at Frank James Park at 2 p.m. and one on Saturday, November 29th at Ken Ford Boat Ramp at 2 p.m. So those are organized by the aquarium. We did want to make sure everybody heard about those. And then the first question came in from Pat. She was wondering, how effective is first and secondary treatment in removing microplastics?
Mm-hmm. I think from what I've read, often they're studying secondary or tertiary treatment sewage. I think actually the primary can be one of the most effective stages because like the microplastics will get caught up in like the sludge and things settling down. So I think that can remove like 80 to 90% or something of microplastics from like the sewage going to the environment. And then I think the more treatment you do from there, like you just get higher efficiency in terms of removal. But you're never getting like 100% of them really with sewage treatment.
And then Galen shared some facts about cleanups and basically, okay,
I'm
this
just
was a
reading
long
through
one.
his question now so I can, yeah, so he was asking about, so he said that Galen was part of a cleanup and they saw around 50% of the waste from fishing and aquaculture by volume, which doesn't surprise me. I think a lot of the macro stuff, like the bigger stuff especially, does really tend to come, especially internationally, from like fishing and aquaculture. And there's definitely, you know, that's 50%, but the rest is definitely going to be like these smaller consumer goods. And I often think too, like those things might just become microplastics faster. So I think we tend to see this ginormous stuff because it's just floating around and lasting for a really long time. In terms of what is micro versus macro, that is a hard question. That's probably not a great question for me to answer. I know there's like Eric Van Sabeel, who's a researcher in the Netherlands, I think, does a lot of this modeling work, looking at these different things. So there is information out there. I don't know it offhand, but it's also hard with the micro stuff because we don't have the best data at all times in terms of how much is out there. I believe, like, for example, in the North Pacific garbage patch, I do know that if you look at actually I think if you look in terms of weight, the micro stuff is actually a lot more predominant than the macro. So I think a lot of it is actually microplastics.
There's another question from Sally. Do clothes dryers send the micros into the air?
Yeah, they do actually. There was a recent study I saw on that too, and they looked at the air blowing out, and they do to some extent. Like I think a bunch of it gets taken out like in your lymph trap, but they definitely do also blow them into the air.
And I had a question. So when you, in the study of human consumption, it was found that most of the microplastics that were in humans from air, water, et cetera, were from textiles. But when you look at where most plastic comes from, it's from packaging. So I'm wondering, is that a difference in basically how long those different types of plastics last in the environment?
Sorry, so are you talking about when we're looking in like food items, what we
Yeah,
see?
because I think the paper that showed the microplastics that people end up consuming, that those are coming primarily from textiles.
Yeah, I think,
But
yeah.
most plastic use is like, you know, plastic wrap and disposable food or whatever.
I think there is a reason for that, and you know, like I don't necessarily have like a really data backed statement on this, but I would say that my thoughts are really that the reason we see the fibers is because the way clothes are made, those fibers are just really readily available to come off of them and to stay kind of like as these fibers. So the way in which, yeah, the clothes are essentially degrading, we're seeing these larger microplastics, which is what we're good at detecting right now. But I think when people look, so there was a recent study on tea bags, plastic tea bags, you may have seen. Last year, there was one that came out a few weeks ago about baby bottles. And so when we look at like plastic packaging, especially when we heat it, they release a lot of micro and nanoplastics, but they're really, really small. And so they had to use really special methods to measure them. Not the standard methods in our field. They had to go into these like really analytical methods. And so I think what is going on is like the plastic packaging, what it's releasing is just way smaller. And so we just haven't gotten good at detecting it yet. But I think we're going to start to like hear more and more about that as our methods start to get better.
Okay, so that's more of a detection problem.
Yeah, I
Possibly.
think so. Yeah.
And Lydia is asking, is there a country that's dominating microplastics research?
Yeah, that's a great question. I would actually say, interestingly enough, China, because China has, the Chinese government has funded a massive amount. They have like basically like a microplastics research network of, I believe there's like over 30 something universities with a ton of funding. So a lot of the papers on microplastics come out of China, although there's more and more, there's a lot in Europe as well, UK and Europe, as well as in the US, and then Canada starting to do it more as well. But, you know, we don't have a ton of population, so we're always playing catch up a little bit.
Mm-hmm. Does anybody have any other questions they'd like to put in there?
Ken asked about my drum set.
Oh, I missed that one. I don't know how I missed that one.
My electronic drum set for playing at home and not annoying my neighbors.
Okay, and sorry, I did miss one from Beth. Does anyone know which plastic bags are recyclable? And I think you kind of touched on that a little bit. I know that one's come up in a few conversations where people say, oh, that biodegradable bags, they just break down and they produce microplastics anyway. So they're really not any different than a plastic bag. Is that true?
Yeah, I think that it's kind of hard to know sometimes. Like some people, you know, I've heard from some people in government and industry that like some of the compostable stuff actually gets composted. And then I've also heard other stories on the other end. So it's always a little hard to know. But if you are using like the soft plastic, regular grocery bag sort of plastic ones, I mean, I would say it's better just to have a reusable bag. But if you do have them, I collect all of mine. And then I also like Recycle BC has like a sort of test program now for the flexible plastic packaging, and so I also save all of those. And so that's any kind of mix, so like a mix of like plastic and foil and things, like often you see those, and those are really not recyclable, and so you can collect those as well. And so with the soft plastics, I'll take both those into like London Drugs, some of their locations do collections. And I know with the soft plastics, like I have a friend who works for the BC government in recycling and extended producer responsibility. And according to him, depending where you are, but like the soft plastic bags, they should be, if you take them to recycling depots and stuff, they should actually be getting recycled into new plastic bags. With the flexible plastics, the newer program, it actually goes into like, they're basically impossible to recycle, but they are going into like a waste to energy stream, I think, in BC. So they'll burn them for fuel, basically, for like actually in a cement factory, as far as I know.
There's one from Sally. Is there paint that doesn't have plastics or acrylic in it?
That is a good point. I don't really know enough about paint to answer that question. I would imagine so. But I'm not entirely sure. There must be some commercial paints. Like there's so many different types of paints, I imagine.
Yeah. And then Galen was asking, just to clarify, if we are involved in a beach cleanup, is there one kind of plastic we should be concentrating on with higher priority than another?
I don't have really a good answer to that other than just the big stuff, because the bigger it is, the more microplastics it's going to produce, and the more potential effect it could have, I would say. So I think some of that big stuff is probably the best, like especially going and try to pick out all the tiny stuff, it's just kind of a losing battle. I think trying to target some of that really big stuff and like some
like
of
the oyster, like the big crates, the oyster crates that you find on the West Coast.
Big trays and like some of those big nets and things.
I was wondering about clothing recycling, because I remember watching a documentary quite a while ago. San Francisco had this fabulous, waste diversion where, because I have piles of like old t-shirts that they, they're not going to go to a secondhand store because they're stained or they're ripped or they're old.
Yeah.
And I've looked everywhere, like Vancouver, Victoria. I cannot find anywhere in Canada that
Really?
takes clothing to recycle.
They do add so recently I use as an app, and there's also a website called Recyclepedia that I've used, and they say for those stuff you can take to Salvation Army, which I have done, and I've told them, hey, this is stuff that's not resellable, and they're like, yeah, cool, we'll put it in. So they claim to have textile, like some linkage to textile recycling.
Mm.
I have no idea what actually happens to that
Yeah,
stuff.
I asked our guys, they put it in the dumpster.
Okay,
But they do say if they're not too bad, I guess they look at it, they give it to companies that'll like local companies that use it for rags.
oh, maybe that's what it is
Yeah,
then.
but
Okay.
so then when they take like playground equipment, like these things that are basically like 2x4s made out of plastic,
Yeah.
how are those being made?
The playground. It's probably, yeah, coming out of recycled, like the plastic lumber. I
Yeah,
think they're talking about.
yeah,
Yeah, I think that's coming from recycled plastic. So that's often just a mix of like a bunch of stuff that's maybe otherwise unusable, and so
right.
it's all just melted into like yeah, just like a plastic brick, I guess. Oh, the other thing I would say, I don't know how legit it is, but I know H&M had some program where you could like drop off textiles there, and they claim to also be recycling.
Oh,
I've never done it, and I don't know how well it actually works. But with these things, I feel like there's never that much transparency in terms of what actually happens to them.
yes.
It's kind of a
And
shot in the dark.
I think we'll take this as the last question. We've just gone a little bit over time.
Yeah.
Emily's asking, what's the average amount of microplastics that humans consume annually? Like we saw the results of your paper. Is there other paper there? Is there any other research that way?
Yeah. So like, yeah, so going back to this slide here, we estimated in our study that it was around 74 to 122,000 per year, but that's kind of a low end estimate. And then this other, they extrapolated from some human stool measurements to be maybe it's upwards of 1 million. But like, yeah, it's kind of early days. And so I think it's probably higher than that. But then it's like, we also don't really know what that means because we don't know what actually, causes harm. Is it 1 million? Is it 1 billion? Is it 1 trillion? And until we know that, these are just numbers.
Yeah.
Yeah.
Well, I'd like to thank you so much on behalf of the Campbell River Arts Council and the Museum at Campbell River and Greenways Land Trust. We really, really appreciate your time to share your knowledge with us, and we appreciate your time sharing knowledge with everyone that you do. That it's so important to understand the human impacts on our environment. So
Yeah.
thank you everyone who came tonight. We really appreciate your participation in the event.
Yeah, thank you so much, everyone, for coming. It was really great talking to you.
Good night, everybody. Nice to see you.